The time has now come for our keynote, which will be delivered by Avanti Sharma. As per her own words, Avanti, pre-teen technology specialist and head of business development at Workshop for Me, stands for the Sustainable Development Goals and encourages iGens, short for Internet Generation, I had to look it up, to play a role in them. Starting with her TEDx about how an iGen would implement Sustainable Development Goals, Avanti has been presenting her ideas on an impressive number of international forums. At the Mobile World Congress in 24, at the Economic Times Global Business Summit in 23, at the Digital Education Stakeholder Forum in 22, and the Economic Times Women in Tech in 21, to name but a few. Avanti's contribution has been recognized by Technology Playmaker Awards in 2018, hosted by Booking.com, by IT Ladies Night in 2019, and in 22 her contribution was recognized by Inspiring 50 Belgium, SheU Leads, and Girls in Tech. Avanti was also interviewed in 2018 for her podcast Dot Complicated by Randy Zuckerberg, influencer, CEO and founder of Hug, and former marketing director of Facebook. And in 2017, she has been featured in Tech Talks podcast by legendary David Savage, group technology evangelist at Nash Squared. Earlier last year, Avanti won the Honorable Award and first place for international delegates at the largest science exhibition in Portugal for Studified, a software she developed. She was also honored by receiving the Aspiring Teen Award at the Women in Tech Europe Awards and representing Europe as a finalist for the Women in Tech Global Awards. On a more personal note, Avanti and her brother taught my son the basics of coding some years ago. But I think by now we're all eager to learn more about extraterrestrial connectivity. So Avanti, can I ask you to please join me on stage?
Hello everyone, it's great to be with you today, and that was such a nice introduction. Thank you so much. But my favorite was the personal note, because honestly, for me, what brings me so much joy is like to see kids once they've made their project and it comes to life, so that's amazing. So I am really delighted to be with all of you here today. Very, very cool setup, by the way. And today, we are going to embark on a fascinating, maybe the first ever attempt to look 100 years into the future and conceptualize how intergalactic communication will look like. We'll analyze how it will work, the risks, the challenges, and what we need to make it happen. Are you all ready? Great. Okay, let's jump in. Yes, epic. So, hey everyone, I'm Avanti. I think I had a great introduction. That's so kind of you, thank you. But yeah, I'm 17, and I'm the preteen technology specialist and head of business development at Workshop for Me. And we work towards changing the children of today into the leaders of tomorrow through programming and other technological skills. So to start, we first have to understand what intergalactic really means. This is where we are. That's Luxembourg. This is Europe. And that's our world. Now, if we zoom out, there's our solar system, and many solar systems make up our galaxy, the Milky Way. Let's just take a moment to appreciate how beautiful it is. And thanks to NASA and Google Earth for these stunning images. So intergalactic means that we connect two of these galaxies together. So here we kind of see a galaxy, and then we see another bright light burst. Now that could be a very bright star, or that could be a galaxy. Galaxies are between 3,000 to 300,000 light years, or 100 to 100,000 parsecs in diameter. So connecting those together. A parsec is 3 light years. So it's the distant unit used when you're measuring in astronomy. Overall, this is how far we would be connecting. So what this means is doing this and connecting these two galaxies is a big feat, and it shall accelerate humanity greatly. Accomplishing it would need years of scientific innovation and research and progress from connectivity's brightest minds. So it's great that we're already starting here today. That's epic. So to make it happen, we need a solid plan from the ground about how intergalactic connectivity will look like. Let's start with its dimensions. There are 3 main dimensions to intergalactic connectivity. The first is a time and space transmission using Einstein's theory of relativity and wave-particle duality. So, a quick recap of quantum chemistry. There are 3 main parts of an atom. Its nucleus, basically a positively charged sphere, with protons in it. Then we have neutrons in the nucleus as well, and then electrons orbiting the nucleus, which are negatively charged particles. So most of us in science lessons have probably seen this diagram, and electrons are the ones which play the greatest role in deciding an atom's reactivity or their stability and different characteristics. Now, in reality, this is how we've seen it, but in reality, it looks more like this. It's kind of like a cloud of electrons moving around. We don't really know where they are, and we rely on probability to say that they are somewhere in between here. But in reality, they could be anywhere in the universe. And this is called Heisenberg's uncertainty principle. So, one more thing. Up until 1924, we considered all of these kind of electrons to be particles, which means just small portions of charged mass. And all of the characteristics we associated with an electron was that of a particle, so basically like a tennis ball. Einstein performed an experiment called the double slit experiment, which found that an electron can behave like a particle and a wave. So what this means is it actually decides based on where we look at it. But when we aren't looking, it is both at the same time. Very, very cool. And interestingly enough, we found the same behavior in light, which is an electromagnetic wave. And as you may know, electromagnetic waves are used to transmit Wi-Fi. This is perfect for intergalactic connectivity. Let's discuss why. While traveling through space, our message may encounter a black hole. So, to circumvent it, either light has to bend, or we have to use a feature of the electron as part of the electromagnetic wave, which could be present here or anywhere in the universe around us. So if it could be present anywhere in the universe, it could also be behind a black hole. And that's why we have to use all 3 dimensions of the atom for intergalactic connectivity to work. Let's move on to the second dimension, which is the packet-based transmission. So the current protocol of wireless fiber, or Wi-Fi, is to send small bits of information called packets to the other end, to a receiver. And the receiver assembles packets together in the correct order to read the message. According to Einstein's theory of relativity, each galaxy has its own time and space dimension. So it would be interesting to see what happens with our packet-based communication. And a quick summary of what this means is basically 2 observers in a relative motion experience time differently. So 2 events could happen at the same time for one observer and at a different time for the other, and both would be correct. Also very, very cool. Okay, so going over to our very solid plan, we would need senders and receivers on both ends of the galaxy. And those will be, wait for it, very new, they would be a satellite. So, we already have a very detailed model ready. We just need some investors to make it fly. So, the economic return of this will be earned by the great-grandchildren of Avanti Sharma with a guaranteed return of 2,000% ROI. And this guaranteed return is guaranteed by Avanti Sharma, and the great delivery will be by her grandchildren. So, jumping over to the third dimension, localized energy production. To make this work, we need to discover a new concept called continuous, localized, moving fission, where a portable device in which protons will continuously bombard heavy metals like uranium and thorium to create nuclear energy to support our satellite communication system. The radioactivity coming out of this process could be used to create a multi-dimensional communication spread of the same signal, which will be captured by the satellites, organized in a Starlink architecture to ensure the integrity of the message and the backup message is also maintained. So quick refresher on how this would work. Fission kind of involves splitting an atom into two with a neutron, which releases a ton of energy, and then other neutrons will hit another atom, and the process continues. And fission is very efficient for this intergalactic process, as it is 8,000 times more efficient than burning fossil fuels. The downside to fission for us is that it produces nuclear waste, which takes 200,000 years to decay. By the way, radioactive means that, it releases UV rays, like X-rays or gamma rays, which are at the end of the electromagnetic spectrum. So this is bad for us, because it's cancerous to us humans, but in an intergalactic world, if it's away from us humans, there's no problem. Today, the radioactivity coming out of nuclear fission will be seen as a burden. Tomorrow, it will be seen as a bliss because it diffuses communication signals everywhere quite rapidly at minimum possible energy compared to today's scenario. The long half-life, a source of great worry, will be a great joy to the intergalactic world. So now that we have the dimensions in place, let's move to the prerequisites. So firstly, we need completely different units for this to work. Otherwise, our computers will fail. It's like putting a million digits on a calculator. Even the supercomputers will fail. All the units we are currently using must increase by a factor of 1 billion. And computing power must also increase by a factor of 1 billion. So Moore's law, the number of transistors on microchips must multiply by 500 every 2 years. On the supply chain side, rare earth minerals are limited, so chemists and material scientists must discover an alternative method which could be used for communication. Silicon will become the next gold, and we will all be rapidly chasing to discover all of the new minerals, not just on Earth or on asteroids. Next, a system to clean up space debris must be invented, and the joke of yesterday by the United Nations must be adopted as a real commitment to the future. We need that SDG for intergalactic communication to happen. And lastly, we must prepare our next generation for this shift. To address the rare earth mineral problem, all the missing elements have to be found, and 50% of the current generation must take up material science and chemistry with subsets of mathematics to be able to compress a 23-year-old of today into an 11-year-old of tomorrow. And to do this, time has to be saved. We don't have the time to wait in a grocery store or get our parking ticket. These luxuries of today have to be given up, unfortunately. If we take 3 hours a day each year on just school years, that's 37 days, which is and in a decade, that's 1 year and 2 weeks. And in 18 years, that's 1 year and 9 months for just school days. This time has to be used on education. Now, to completely check whether children are prepared on this level, we must carry out an important test. The children will be asked to draw their version of a dinosaur. And if they draw us as human beings, we will know that we are ready for our transition to intergalactic communications. So now that we're done with the groundwork, let us go, 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 go. So, the rollout and implementation. So right now, it is most probable when we're implementing it that we will kind of have to rely on alien species to set up the other ends of communication. And for this, what we need to do is we need to outsource a small portion of work to them. This is important because without this, we won't be able to make this happen. A small communication system should already be set up with the moon, and once that is done, the same team should immediately travel to Mars because it'll take 1 year and 9 months to get there. Now, going on to the final thing, the challenges. So the challenges of communication of the intergalactic world are likely to be a similar one of the ones today. And I'll go through this quickly. The first is eavesdropping. So it's more for, not for the aliens, but from people on our side of the planet. Aliens may have a different type of life, relationship, or mental thinking than us, but humans on our side of the galaxy are likely to continue the same habits. So a solution to this end-to-end encryption must be found. The second is IPR protection. So we will notice that when we outsource the work to aliens, then we'll probably face some communication gaps, and it is likely that in a point of time, they steal our methods and ways of working. For that, an IPR protection system is crucial to maintaining our intergalactic communication. Lawyers must be well versed in 2 to 3 programming languages, in 2 to 3 alien languages, and schools must also adopt this for their next generation. Whenever we have a fête de voisins, it will be impolite not to invite them. Now, the last is implementation. Once all of this is done, we will implement this system to be able to have a complete communication system with the other side of the world. And when all of this is done, we will see that myconnectivity.lu will grow to become myconnectivity.ig. And, quick advice, book this domain name ASAP. Okay, so now in all seriousness, I want to kind of conclude on the note that nature is really beautiful. And right now we're talking about intergalactic connectivity, but I think it's also important to respect the climate and the world around us, for not just for us, but for our next future generations, as nature has done the same thing and replenished us and made us grow and prosper like our mother. It is our duty to show the next generations not only that we care, but also that we're responsible. And that will be the legacy which we leave behind. So these are some beautiful pictures, and this is where we live. So I think it is our responsibility to protect and conserve it to the fullest. Thank you so much.